In this video, I'm going to talk about slope and inclination of straight lines in coordinate geometry. Let's take a look at these two straight lines. The first straight line is formed by points A and B, and the second straight line is formed by points C and D, and we know the coordinates of these 4 points. The slope and inclination are used to measure how steep the straight line is. And when we take a look at these two straight lines, we can see that obviously AB is steeper than CD. But how can we measure how steep a straight line is? The first way is to use a measurement called slope. Slope means that when I move horizontally by 1 unit towards the positive x-axis, how many units I need to go up so that I can reach the straight line again. The required distance here is the value of the slope. Therefore, the distance here is the slope of line AB, and the distance here is the slope of line CD. Because we can see that the distance here is longer than the distance here, so we can conclude that the slope of AB is larger than the slope of CD, and therefore AB is steeper than CD. By referring to the grid lines, we can easily see that the slope of AB is equal to 2, because that's 1, 2, 2 units. And the slope of CD is equal to somewhere between 0.6 to 0.8. Usually, we do not have the grid lines provided to do the counting, but instead we have the coordinates of the points. Let's see how we can calculate the values of these slopes by the given coordinates. To calculate the slope of AB, we can take a look at this right-angled triangle. The length here is 4 because that's 5 minus 1. And the length here is 2 because that's 3 minus 1. Because this smaller right-angled triangle and this larger right-angled triangle are similar, therefore by corresponding sides of similar triangles, we should know that the ratio of this side to this side is equal to the ratio of this side to this side. Therefore, we can conclude that the slope of AB is equal to 4 over 2, and that's 5 minus 1 over 3 minus 1, and as a result it is equal to 2. Similarly, to calculate the slope of CD, we should first of all calculate this length, and it is equal to 3 minus 1, therefore it is 2. And we should also calculate this length, and it is equal to 7 minus 4, therefore it is equal to 3. By considering the corresponding sides of similar triangles, we can conclude that the slope of CD is equal to 2 over 3. That means 3 minus 1 over 7 minus 4. Therefore, it is equal to 2 over 3. Now let's take a look at a more general case. Suppose we have 2 points A and B, and the coordinates of A are x1 and y1, and the coordinates of B are x2 and y2. And we assume that this straight line is upward sloping. That means it is like this, but not like this. Then the length here is equal to y2 minus y1, and the length here is equal to x2 minus x1. As a result, the slope of this straight line is equal to y2 minus y1 over x2 minus x1. This formula is called the slope formula, and we can use this formula to calculate the slope when the coordinates of 2 points are given. The slope formula can also be rewritten as this, y1 minus y2 over x1 minus x2. These two formulas will give us the same value of the slope, and that means when the numerator is 2 minus 1, the denominator should also be 2 minus 1, and when the numerator is 1 minus 2, the denominator is also 1 minus 2. Next, let's take a look at what inclination is. Let's take a look at these two straight lines again. Besides slope, to calculate how steep the straight line is, we can also consider angles like this. It is the angle measured from the horizontal line in the anti-clockwise direction. And this angle is called the inclination of the straight line. And this angle is the inclination of AB. This angle is the inclination of CD. To calculate the value of this angle, we can again consider this right-angled triangle. Now we let the inclination of AB be theta. And then we can calculate the length of this. It is equal to 5 minus 1, that means 4. And the length of this is equal to 3 minus 1, that means 2. And now this angle can be calculated by the tangent ratio. Therefore, we know that tangent theta is equal to 2, and then theta is approximately equal to 63.4 degrees. Similarly, for the inclination of CD, it can also be calculated by the tangent ratio. We can let this inclination be phi, and then we should know that the length here is 2 and the length here is 3. Therefore, tangent phi is equal to 2 over 3. As a result, phi is approximately equal to 33.7 degrees. Now we can see that this value is actually the slope that we have just learned. Therefore, in general, if we let the inclination be theta and the slope be m, then we can conclude that tangent theta is equal to m. Therefore, to calculate the inclination, we just need to consider the arctangent of the slope. Now we have two formulas. One is the slope formula and the other one is the inclination formula. Please pay attention that these two formulas are always correct, even in these three cases. We should also know about the meaning of the slope and inclination when the straight line is downward sloping, horizontal, or vertical. For a downward sloping straight line, when I move horizontally towards the positive x-axis by 1 unit, this time I need to go down so that I can reach the straight line again. And in this case, if I need to go down, then we say that the slope is negative. If the straight line is horizontal, then when I move horizontally by 1 unit, there is no need to go up or go down to reach the straight line again. In this case, we say that the slope is equal to 0. If the straight line is vertical, then when I move horizontally by 1 unit, no matter how many units I go up, I can never reach the straight line again. In this case, we say that the slope is undefined. In these three cases, we can still refer to this slope formula. For the first case, when we calculate the slope of AB, we can consider 1 minus 4 over 3 minus 1. And in this case, it is equal to minus 3 over 2, and that's a negative slope. For the slope of CD, after applying this formula, it is equal to 0, and that's a 0 slope. For the slope of EF, after applying this formula, the denominator is equal to 0, which means it is undefined. And then let's take a look at the inclinations in these three cases. For a downward sloping straight line, the inclination is like this, and it is an obtuse angle. That means it is between 90 degrees to 180 degrees. In this case, this formula is still true, but since theta is an obtuse angle, such concept of trigonometry will be discussed in the senior form. When a straight line is horizontal, the inclination is obviously equal to 0 degree. And when the straight line is vertical, then the inclination is obviously equal to 90 degrees. That's the basic concept of slope and inclination. And now let's take a look at two examples to learn about the applications of slope and inclination. In this example, the 3 points A, B, and C are collinear. And now we need to find the value of K. Collinear means that the points are lying on the same straight line. When the points are collinear, then we should know that the slope of this line segment is equal to the slope of this line segment. That means the slope of AB is equal to the slope of BC. And then we can apply the slope formula to set up an equation in the unknown K. After solving the equation, we can get that K is equal to 6. And then let's take a look at this example. In this example, the coordinates of P, Q, and R are given. Now we need to find angle PQR, and it can be done by considering the inclination. We can firstly let the inclination of PQ be θ1 and the inclination of RQ be θ2. Then tangent θ1 is just equal to the slope of PQ. That means it is equal to 5 minus 0 over 6 minus 3, and that's equal to 5 over 9. Therefore, we can calculate the value of θ1. For tangent θ2, it is just equal to the slope of RQ. That means it is equal to 5 minus 0 over 6 minus 4, and it is equal to 5 over 2. Therefore, we can calculate the value of theta 2. And then angle PQR is just equal to theta 2 minus theta 1 because of the exterior angle of triangle. As a result, angle PQR is equal to 39.1 degrees, correct to 3 significant figures. So this is how we can apply the concept of slope and inclination to solve problems in coordinate geometry.